Happy Monday, everybody. I hope you guys had a good weekend, got to unwind and de-stress a little bit. Today we'll be working on 19.1 graphing quadratic equations. Honestly, you guys already know how to do this. You guys have gotten really used to Desmos this year, and this is no different than any other lesson. So let's go ahead and get started. So what is a quadratic? Well, a quadratic function is in its most basic form is y is equal to x squared, or f of x is equal to x squared. It's honestly just a polynomial. If you remember, we learned about polynomials. It's a polynomial that has any positive exponent. For example, like 3x squared plus 5x minus 7, that is a polynomial. Specifically, this polynomial is called a quadratic. Now, any polynomial where the degree is 2, again, the degree means highest exponent, anytime that highest degree is 2, that polynomial is actually called a quadratic equation or a quadratic function. So, in its most basic form, it is x squared. That's because there is no transformations, there is no vertical shift, there is no horizontal shift. So, a quadratic function is simply a polynomial where the highest exponent is 2. Just like lines have different forms, quadratic functions also come in different forms. So our first one that we're going to look at is standard form, and you guys already know what standard form is. It's organized where the greatest exponent is on the far left, and it decreases as it goes down. So greatest exponent to least exponent. Factored form, we'll actually be learning this soon in the next upcoming weeks. But factored form is where you have something like x plus 2 or x plus a and x plus b. Those can be minus signs as well. So an example that you guys seen a lot was like x plus 3 times x plus 2. You guys already know you have to draw your boxes for that, your mathematical array, and you multiply to fill in your boxes. What this is called, those parentheses, that right here is factored form. Our last form that we have is vertex form, and that is y is equal to a parentheses x minus h squared plus k. Honestly, do not worry about any of these forms at this moment. We just want you to, be able to recognize them, put a face to them, but we will be graphing them in these different forms, and obviously Desmos is going to help us a lot with that. Just like any type of function, quadratics can be graphed, and that's what we'll be doing today. But this shape, this has a specific name to it. So when we graph a quadratic function, that shape on the graph is actually called a parabola. It looks like a U. So you'll see once we actually graph an example that our parabola is exactly going to be looking like a U. There's going to be a minimum point right here. Now it can either open up or it can open down like this. Regardless, whenever we graph a quadratic, and remember that highest exponent needs to be 2, but whenever we graph a quadratic, that shape that it produces will be called a parabola. Now really quick, just before we do start graphing, obviously you guys will not be able to type these examples straight into Desmos right away because you should be, and I'm hoping that you are watching this video, but just as a reminder, when you do go and graph this in Desmos, go ahead and plug in your equation right here like you normally would. But to get specific points that you want to plot, remember you can also hit this gear button or that settings button on the top right. Where that will take you is to this menu right here. And you're going to see a little icon that has a little table function, this guy right there. Go ahead and click that table function and it'll bring you to a page that looks just like this. Now the neat thing is, and I'm assuming you guys already all know this, but just in case, if I tap anywhere on that X column, you guys can type in your own X values right here. And so just keep that in mind when you go and graph specific points. And when you do that, you will get a shape that looks like this. Now obviously the most important points that we are interested in are your x-intercepts if you have any, your y-intercepts if you have any, and that point, that minimum or maximum where you have, where your graph changes directions. All right, let's get to our first example. Alright, so go ahead and plug your equation into Desmos. That's always a very, very first step. So when you plug it into Desmos, you're going to type in y is equal to x squared plus 2x minus 1. Then you're going to hit that gear button on the top, hit that table icon, and then type in these x values just like we talked about before. If you do that, you're going to get the points. Let's see here. Negative 3 comma 2, negative 2 comma negative 1, negative 1 comma negative 2. That's supposed to be just a regular 0, but 0 comma negative 1 and 1 comma 2. Now, if you notice, your y values are repeating, and honestly, that should happen. And we'll talk about that. Actually, no, we'll talk about it now. If you notice right here, negative 2 is that middle point right here. Because you see after this negative 2, your numbers start to repeat. I have negative 1s, and then I have positive 2s. Well, this point right there is actually really important. That point is actually called your vertex. It's either going to be that minimum point or that maximum point, depending on which way your graph is opening. That's where your graph changes directions, and that middle point right there is called your vertex. That's how you can identify it. So let's go ahead and plot these points. Alright, so I zoomed in on my graph just so that way I can get this a little bit more accurate. But you guys already know the table, we filled it out. So I have negative 3 comma 2, I already plotted it right there. I have negative 2 comma negative 1, which is right there. I have my vertex, which is negative 1, negative 2. And remember, that's a point in which my graph changes direction. So after this, my y values are going to repeat again. So now I have 0 comma negative 1, and notice I have the same y value. And I also have 1 comma 2. All I did was plot the points that were on this table right here. That's all I did. But if you look at Desmos, obviously it just doesn't have those points plotted. They actually have it all connected, and it's going to be a U shape to your best of your ability. And it's also going to be continuing on. Now, I'm picky about my graphs, and I don't want you guys to just draw a little U that's like this that takes up a tiny bit of your graph. I want you guys to actually draw your arrows going all the way to the edge of your graph completely. Because quadratics do go on forever. They do go on infinitely. So make sure you just draw a nice, pretty graph to the best of your ability. Alright, so now it's time to find our x and our y intercepts. Now the nice thing about Desmos is you can honestly just tap your x and y intercept and it will tell you what it is right away. It doesn't matter if it's a nice point or if it's a decimal, it will give it to you. So just by looking at Desmos and tapping those x and y intercepts, I know that I'm going to get, as an x-intercept, is negative 2.4 comma 0. And I also have a second point, a second x-intercept, which in this case was 0.4 comma 0. Now, the cool thing about quadratics is they can have up to 2 x-intercepts because of that U shape that they have. But again, they only do have one y-intercept. All functions should. And our y-intercept, again, just by tapping Desmos or by looking at your graph, is going to be 0 comma negative 1. Because all y-intercepts do have that x value of 0 in common. We can do the exact same thing that we just did for that standard form function that we can do for this factored form. You can plug this into Desmos, you can fill out this whole table, you can graph those same points in your graph, you can tap your x-intercept, you can tap your y-intercept. The only difference is that it's in factored form. However, you guys already know when we multiply this out, you're going to get something like x squared minus 6x plus 8. And this is a quadratic because that highest exponent is 2. But it's going to behave the exact same way. It's going to have that U shape. We can have up to 2 x-intercepts, sometimes 1, sometimes none. But it's honestly the exact same process regardless of what form we're in. So even if we do have something in vertex form, okay, you can still plug it into Desmos and do the exact same process and you guys will be fine. So I'm not going to bore you with another example because you guys should know how to do it. Alright, so here is an application problem for you guys. Let's restart that. A ball is thrown in the air from an initial height of 16 feet with initial velocity of 96 feet per second. The function that models this scenario is h of t is equal to negative 16t squared plus 96t plus 16. where t represents the amount of time in seconds from when it was thrown. Graph the function using the table below. All right, so again, all we're interested in is, for the moment, is our function right there. So we're going to tap that into Desmos. We're going to hit that gear button, hit the table icon, and we're going to type in all of these x values right here to get our y values. Now, when I do that, I should get something like -1 comma -96. I'll get 0 comma 16, 1 comma 96, that's a positive 96, 2 comma 144, 3 comma 160, 4 comma 144, 5 comma 96, and 6 comma 16. Now remember, quadratic functions, they should have repeating y values once we hit that vertex. Remember, that vertex is that middle point, kind of where those repeating values meet. So if you see, positive 16 repeats right here, 96 repeats right there, 144 repeats, and 160 is our middle ground, so we know that this point right here is our vertex. So let's go ahead and graph those points now. All right, so if I go back and I look at my table, my first point that's on there is -1 comma -96. Now I know it doesn't exist on this graph, but if I kind of mark it, it's going to be somewhere right here. And we'll talk about that point later in a second. Now I have 0 comma 16, and again, just try to estimate, okay, it doesn't have to be perfect. 1 comma 96, it's a little bit below 100. 2 comma 144. 3 comma 60, 160 that is. And now my y value is repeating. I have 4 comma 144, 5 comma 96, and 6 comma 16. About right there. So if I were to connect these, okay, as I were doing all the rest of them, it would look something like this, right? And I told you guys before, draw your arrows at the end and all that stuff. But this is an application problem now, so I can't just necessarily draw the graph and call it done, because I had to make sure that it makes sense to the problem that I have. Now, the ball is being thrown. So because I'm talking about time as well, I can't go back in time. Well, what is time? Is that our x value? Is that our y value? Well, if you remember, our x value is always our independent variable, and we can't change time. We can't do anything about changing time. So therefore, if it's a unit of time, it's always our independent variable. So I know that our x-axis is going to be seconds. Well, if I look at that first point, if x represents seconds and that first point x is -1, can I have negative time? Well, the answer is no, I cannot. So this point right here actually does not exist in our problem. If it'll let me zoom in and erase, I don't know if it will. There we go. I can't have that point. Come on. There we go. Can't have that point because I can't have negative time. Well, time starts at x equals 0, so that's right on your y-axis. Additionally, I can't have a negative height either, right? And that's going to be our y-axis, is that feet, because that's our dependent variable. But I can't have negative feet because that means this ball is digging a hole in the ground, and that's not happening. It's bouncing. Therefore, it's going to stop right at that x-axis as well. So when I have my graph, it should just be in that first quadrant. It should just be living in that region right here, okay? So that's how our graph looks like. Well, it's going to be the exact same process as it would in Desmos, okay? You're going to hit your x-intercept. Maybe in this case, in this example, we would only have one, okay? We would have our y-intercept as well. And our y-intercept is easy to find because it's actually in our table. Where does x equal 0? It's right there, so 0 comma 16. I'm not going to have this x-intercept anymore because 1 doesn't exist. But I know I have this one right there. And now let's you guys actually go ahead and find that one. You will have a problem like that in your homework. I hope this makes sense to you. If it doesn't, I'm going to be here on Tuesday, so you guys can ask me again on this problem. But I'm not here today, but if you do have questions, please email me. I will be around my computer. There we go. But I hope you guys have a great Monday, and I will see you guys tomorrow.